Hello and welcome to section 4.8. This is applications and models of trig functions, and so in this one we're going to go through and start with a basic example of solving the triangle, which basically means find the missing angle, find angle B, find A and C. So we want to know what angle B is, what side A is, and what side C is. That's our goal. Well, angle B, to find that, is basically going to be 90 minus the 34.2, which comes out to be 55.8 degrees. So there's our angle up there. That's part of our solution to this. And then if we want to find A, I might do something like, and you just got to remember our trig functions from geometry and algebra 2, that the tangent of 34.2 would be equal to A over 19.4, and I'm going to multiply by 19.4, so 19.4 times the tangent of 34.2 will equal A. And if I get out my calculator, I would have 19, make sure your calculator is in degrees, times the tangent of 34.2, since we're using degrees up there. And so we get 13.18 for our measure of A. So A is 13.18, and then to find C, I'm going to use I'm actually going to use cosine, because I don't want to have to use A, which was an estimated one. So to find C, I'm going to say the cosine of 34.2 will equal the adjacent, which is 19.4 over C. And remember that these guys can swap places to find C, so it's 19.4 over the cosine of 34.2. So if I take out my calculator, I end up with 19.4 divided by the cosine of 34.2. And that gives me 23.46. So that is my C value. And so a 23.46 would be my C value, and that's solving the triangle. That's really what we needed to do. So in my next example, I am asked, it says the safety regulation states that the maximum angle of elevation for a rescue ladder is 72 degrees. A fire department's longest ladder is 110 feet. What is the maximum safe rescue height? So I'm basically looking for A when I'm basically just looking for A in this case when I want to find out how far up the height could be. And so I'm going to do that with using a trig function. You'll notice that I'm looking for the opposite when I have the hypotenuse and an angle. So that would be sine. So sine of 72 will equal A over 110. And if I if I multiply this over here, I would get something that looks like this for A. And so if I take 110 times the sine of 72, and remember we're still in degrees, it should be 104.62 would be the height above the ground that I could reach, or above the fire truck actually in this case. So 104.62 feet. 104.62 feet was what I can reach to. And so that's just an example of why we might need this. Alright, so then the next one we have at a point 200 feet from the base of a building, the angle of elevation to the bottom of the smokestack is 35 degrees, and the angle of elevation to the top is 53 degrees. Find the height of the smokestack. So what I'm going to do is I'm going to start with this 35-degree angle triangle and find A. Then what I'm going to do is use the 53-degree angle and find S and A combined. And then I'll subtract A from S and A, and then it'll obviously give me S. So if that's the case, well, you'll notice that I'm looking for the opposite when I have the adjacent, so I got to use the tangent. So the tangent of 35 is going to equal A over 200. So that's going to be 200 tangent of 35 will equal A, will equal that value. And so if I do that, 200 tangent of 35, again I'm in degrees, I get 140, we'll say. So A is equal to 140. So then if I want to find S and A, I got to use the whole 53 degrees, and I'm still going to use tangent in this case. So the tangent of 53 degrees will equal the opposite, S plus A divided by 200. So if I multiply these across, 200 times the tangent of 53 will equal S plus A. And so then I need to calculate that. And so 200 tangent of 53 tells me 265.4. So S plus A will equal 265.4 feet. And so then if I subtract A from this, then I'll just get S. So if I minus 140 from this, it looks like I'm going to get 125.4 feet would be the height of the smokestack that we were looking for, give or take a little bit. And so basically we're just using trig to help us out with this. So then here's a definition that you need to get down about bearings. And bearings are basically your line of sight from a north-south line. So you'll notice that they're telling me what line, S is what line I'm using. I'm using the south part of the line, and I'm going 35 degrees east of south. So that's basically what I'm looking at. Over here, I'm using the north part of my axis, and I'm going 80 degrees west of it. And over here, I am 45 degrees north, or I'm using north 45 degrees east of that, which puts me on this line over here. And so bearings is just using the north-south line and how many degrees east or west you're going from that north-south line. And then a definition of harmonic motion, you basically just need to write this down. This is some definitions that you need to know, so please pause it. Also, along with this, you need to copy down this definitions and basically how the harmonic motion affects sine and cosine. And so this is an omega, the lowercase omega, I believe. And so we're going to go ahead and we'll use these guys for our final example. And so in our final example, make sure you get these down. In our final example, we are given the equation this, and we want to find maximum displacement, the frequency, the value when t is 4, and find at least one positive value for t in which d equals 0. So basically, if I want to find out the maximum displacement is basically the amplitude. And the amplitude, if you guys remember from before, displacement is amplitude. And so you can see that that's going to be 6. 6 units of whatever we're dealing with. So then they ask us to find the frequency. And remember, frequency, we just gave the equation, is omega divided by 2 pi. And if that's the case, well, that's the same as the number in front of our t variable. If you look back at what we had, so that's going to be 3/4 pi divided by 2 pi. 3/4 pi divided by 2 pi, which then will work out to give us 3/8. 3/8, and this is cycles per unit of time. So cycles per unit of time, whatever that unit of time is for this one. So then if we want to find out when what happens, the value of d when t is 4, that's just a matter of me plugging in 4. So d will equal 6 times the cosine of 3 pi over 4 times 4, which basically means it's the same as 6 cosine of 3 pi, which when I crunch this number, well, when I get this, wait. So when we get, for this one, we end up with 6 times the cosine of 3 pi is the same as pi on the unit circle, so that is -1, which means that my d value is -6 in this case. So at time 4, it looks like we're at the bottom of the spring that has been coiled down. So find the least positive value of t for which d equals 0. So in this case, we're just going to replace d with 0. So we're going to say that 6 cosine of 3 pi over 4t needs to equal 0. So we're going to solve for this. We're going to divide by 6, which would give me cosine of 3 pi over 4t equals 0. And then I need to find out when cosine of t equals 0. So t will equal 0 for cosine when we get at pi over 2, unit circle, 3 pi over 2, and then it can continue around 5 pi over 2, and so on and so forth around the unit circle, around and around we go. So then if we want to find the values, then basically what we're going to say is that's when cosine of t equals 0. So we're going to have 3/4 pi of t equaling to these guys. And if we were to solve, we could find out, we're basically multiplying by 4 pi over 3, so let's just do pi over 2, and then you guys can continue the rest. And so then t will equal pi over 2 times 4 pi over 3 pi. 4 over 3 pi, the pi's cancel out, and I can cancel out, reduce it by 2. So it looks like I would get 2/3 of whatever unit of time, and then I could put in 3 pi over 2 for t, for what it's equal to. So I would go 3 pi over 4t equals 3 pi over 2 and solve for t again. That'd give me another moment in time, and so on and so forth, to find out when when the spring that we're talking about is back at the 0 point, because that's when the displacement, d is our displacement, and that's what we're talking about for this. So if you have any questions about this, please come to class prepared to ask them.